Welcome to the last session of the first day of DebConf. And we are listening to Nolan Leake, who will tell us about our own private cloud. Thank you, Nolan.
Thank you very much, and thank everyone for coming. I know the stiff competition with the reproducible build talk next door is there, so thank you for coming to see this talk. We're going to be talking about Boundery, which is a platform for hosting kind of cloud services in your home. And we're going to primarily be talking about hosting your own email as a proof of concept, just because that's kind of the first app I've worked on, and because it's kind of a good motivating example. So first off, a little bit about me. I'm a long-time Linux user and long-time hoster of my own services, so this is all kind of personal interest to me. In a previous life, I started a Debian derivative called Cumulus Linux, which is a operating system for network switches like you'd find in a data center. So 32 by 100 gig switches, not normally stuff you'd find in a home. And they're also a sponsor, so thank you, Cumulus. I'm no longer involved with them anymore. So, quick poll. Raise your hand if you have a home server or a co-located server or a VM. Okay. What if you raise your hand if you run your own mail server or use a mail server run by family or friends? Okay. Raise your hand if you used to run your own mail server but stopped because it got like really annoying. Excellent. And then finally, amongst the people who stopped and do not, who would run their own home email server if it didn't require a lot of maintenance and keeping up with spam techniques and deliverability and all the other stuff that makes this a fun challenge? All right, a few. Excellent. Well, so Boundery is a platform to enable things like that, enable you to host the services and the data that you use in your own home on hardware that you own and control using 100% open source software and without having to know a lot about Linux or sysadmining or computers in general, actually. So to back it up a little bit, I want to talk about kind of why someone might want to do this. I suspect most of the people in this room are, given that this is DebConf, are going to be fairly plugged into these sorts of reasons and way ahead of me, but I'll go through it just for anyone who isn't. I think people are increasingly aware of how the incentives of the big commercial consumer clouds have become kind of misaligned with the end users. It's like you sign up for a Gmail account, they give you however many gigs of storage space, and so you're basically immediately costing them money from day one. And so they're going to try to figure out how to get that back, right? Like they're not in the business of losing money. And most importantly, they don't really care how you feel about how they choose to make that money back because, from their perspective, losing one customer that's not paying them anything is just not a particularly concerning thing. And this perverse incentive leads to a lot of kind of negative effects. One is they're going to try to trick you. If they have figured out some way to make some money, they're going to try to trick you into giving up more data than you'd intended. They're going to try to, upsell you on other services. And generally just, they're not going to have your best interests at heart. And a lot of these same large companies are busy building more data centers, which they call edge data centers, much closer to the users. So, say Google has a bunch of big data centers in a handful of locations around the world. They also build a bunch of smaller data centers or co-locate equipment in data centers, even more locations in the world. And the goal is to have physical proximity to users to improve latency, because a lot of kind of the experience of these online services is driven by latency. And so, thinking it's really hard to get closer to a user than being in their own home. And then kind of another big one is that people are kind of building a lot of Internet of Things devices. And right now, the common way to do this is that you buy some device, you somehow connect it to some service that's hosted in some cloud somewhere, and it talks to that cloud. And if it needs to talk to a different IoT device in your house, it talks to that cloud and then back into your house, which leads to some fairly ridiculous situations, like I flip a light switch and a packet goes out to a data center, 5,000 miles away, another one comes back to tell the light bulb that's 10 feet away from the switch to turn on. This is obviously kind of inefficient and a silly way to design things, but that is often how they are designed. And this has obvious consequences if your internet connection goes down. It's time for bed and you can't flip the light switch off. And other IoT devices are actually even more sensitive. I'm not all that concerned about some company knowing when I turn my light switch on and off. I'd rather they not have that data, but it's not that concerning. But if I have security cameras looking, out my front door, watching, everyone that comes and goes to my front door, maybe I don't want, Google or Amazon to have full access to that data at all times. And I could talk for hours and have a very depressing talk about the other issues with these large companies aggregating enormous amounts of data and not really caring about the secondary consequences of that, but I'll try to keep this talk a little lighter than that. So my general insight is that, I've been running mail servers, many of you have been running this, but it doesn't really matter that much if just a small, tiny subset of people opt out of these kind of centralized surveillance systems. The network effects matter. Using email as the example, probably more than half the people I email are using Gmail either with their own domain or literally at gmail.com. And so Google's getting a plain text copy of all those emails anyway. And there is a concern, as these big tech companies get bigger, using what they view as legacy protocols like SMTP to communicate gets less and less interesting to them. All these big companies come up with a chat service and they have an XMPP gateway. And then once they get big enough, they decide, hey, it's too hard to keep compatible, or it's a security risk, or whatever excuse they come up with, and they turn it off. And there is a real risk that as email consolidates down into just a handful of large providers, that they could make a backroom agreement of a similar nature to send email amongst themselves using whatever protocol they work out and just turn off the SMTP gateways entirely. So, got into, the user must own the hardware and data to kind of avoid this misalignment of incentives. Because that way you don't have that company, feeling legitimate pressure to, monetize you. And, there's kind of a hidden benefit that this is a lot more emotionally vivid than like two guys in a suit going to some, big company and saying, like, give us this hard drive or we shut down all of your customers' data, or you can just give us this one, and, they probably just give in, right? What do they care? But to reach kind of the larger audience, we can't expect everyone to be a sysadmin. Many of us enjoy managing and maintaining Linux servers and playing with them and stuff, but a lot of people don't, I've observed. And so the system needs to be actually designed, kind of oriented around not ever requiring any maintenance. I'll bring up Freedom Box here, which I think is kind of an interesting, not competitor, but a thing in a similar space. It's very focused on making it easy for people to get started hosting services on a Linux server, but it still very much exposes Linux there. And the expectation, which I think is a good one, is that if you're so inclined, it's a great way to start learning more and more and more. But I'm actually interested in people, users who don't really have any inclination to learn more. They just want to have email or want to have whatever. So we end up kind of leveraging a lot of techniques that are common in embedded systems and cell phones, mobile phones, and things like that. So the root OS is read-only. We dodge the whole systemd conflict by having init be just a single shell script, and this makes the system more reliable. It's often, if you're using something like a Raspberry Pi, it's stored in an SD card, and so those can easily become corrupted if you're writing to them. In this case, it's read-only, so there is very low risk of it getting corrupted. And it's also very easy to do an automatic update, because you can just write the new image to a slot A, slot B, and then reboot. Similarly, the applications like email are broken up into many different read-only containers. One for kind of incoming SMTP, spam, all the various parts that make it up. And so then the user data, which in this case is basically your maildir, is stored separately. And so that's the only read-write part. And so if something goes wrong with the email service, I can just uninstall it and reinstall it, and any kind of corrupted derived state will be cleared out. And this is very similar to what people naturally do with a cell phone app, where if it stops working, they'll go and uninstall it, reinstall it, and usually it just starts working again. And this is kind of a depressing state of affairs, but that's how most people interact with technology. And so, I like to say that what we end up doing here is taking techniques that these large data center operators have developed to have 100 people manage 100,000 servers, but make it so that 1/1000th of a person can easily manage one server. And so from the management ends up being via a mobile phone app or a Linux or Windows or Macintosh app for if you want to manage it from your laptop. So it has a simple app store that anyone that uses a cell phone, mobile phone app store would be familiar with. You just kind of scroll through what apps you want. You see email, hey, that's probably interesting. Try it, and hopefully some other app caught your eye. Maybe you want to try GitLab next. And the idea is to keep kind of configuration very simple and minimal. I like editing text files in Etsy and tweaking every last kind of detail of my setup, but a lot of people just don't have time for that, nor do they have any interest in that level of configurability. So it needs to be cheap and easy, obviously. And so a lot has changed since I started hosting these things back in probably 2001. And now, like, $35 gets you something that's more than powerful enough to host the basic services that most people use. So you could buy a Raspberry Pi. There's a lot of really powerful older PCs that people have retired mainly just because they don't know how to install a newer version of Windows on them, so they just go buy a new PC. And so those can be acquired very cheaply. And my personal favorite is old laptops. They make excellent servers because they use very little power, and they have a built-in UPS. And so another component is that the hardware itself has to be fairly disposable. If my server doesn't come up because it's in single user mode, complaining about the file system being in some bad state, and I need to run fsck-y or whatever, it's an annoyance for me, but that would be absolutely a deal breaker for someone who didn't know what fsck was, and had no idea how to get their email back. So to that end, the hardware itself, the user data is backed up continuously, and each backup is basically ends up being a hash of the first hash of a Merkle tree, and so then that can be backed up off-site. And so that way, all you need is the decryption key to decrypt that hash, and then everything else can then be pulled out and decrypted from the backup. And I'll talk a little bit more about the backup later because it is both interesting and not fully fleshed out. So. And so the other part, especially with something like a Raspberry Pi, the OS image and the root encryption key that all the other keys are derived from is stored on an SD card. And so once you've booted off of it, you can pull it out, stick a different SD card in there, and then go to the app and tell it to replicate on it. And the idea is that I can make 3 copies of these. One stays in the machine and is actually used by it. One maybe I put in a trusted friend's house, and maybe one I bury in the backyard. And the idea is, even if my house burns down, if I can get one of these, go spend another $35 on another Raspberry Pi, plug it in, I should be back up and running, fairly quickly without having to, do anything special to restore. So, around security, this is fairly just best practices, but the local data on disk is, of course, encrypted. It's got built-in support for Let's Encrypt, so it'll generate TLS certificates for every service, individual TLS certificates, so a compromise of one service cannot impersonate a different one. All of the internal services are only listening on a encrypted overlay network, which is it's essentially a VPN. I'm using zero tier right now, and the idea is that if I have an IMAP server, I don't want to necessarily put it on the public internet just so my phone can get at it. But a lot of people end up doing that just because it's very convenient. And so the idea is, by instead of having this VPN, all of these things like, your IMAP server is no longer listening to just anyone who might attack it. They would have to first get onto the private network, and only then could they attack your IMAP server. So it kind of reduces the attack surface you're exposing to the entire internet. And as I alluded to, the services are broken up into individual containers. And the networking is then limited to just what they need. So, the incoming SMTP server can then turn around and talk to the spam assassin server, which can then turn around and talk to the Dovcat IMAP server. And we can actually even take one step further, which are stateless services like the incoming SMTP server and spam assassin, we can restart it after each email. So that even if you had some spam assassin exploit, all you would see was the email you sent that executed the exploit. Any emails that had already been sent or are gone, and subsequent emails would be in a different container as well, and so you won't be able to get at that. And this is, I think, I picked spam assassin on purpose because it's kind of one of the more terrifying pieces of software we run, like second only to a web browser, because it just sits there waiting for the internet to send its most malicious traffic to it, and then does a bunch of deep parsing on it, using a whole bunch of Perl code. So, being able to isolate that, I think, is a very, very good thing. And similarly, the limited networking means that if I compromise the SMTP server, all I can attack is the spam assassin container. I can't, say, attack Dovcat. So even if I had a chain of exploits, starting with postfix and ending with Dovcat, I wouldn't have to find some other way to bounce through the spam assassin, so I'd have to have a spam assassin exploit as well. So I'm going to try to do a demo here. The full demo, the first boot and flashing the SD card takes about 15 minutes, and so I didn't want to make everyone sit through that. So I actually started that earlier. But I will show you a screenshot of what that looked like, and then hopefully I can plug in and go from there. So cross your fingers. Screenshots here. Okay, so this is the thing the user first sees. The idea is you download the app, either, in this case, I think this is probably on, this is on Linux. You download it, you install it, and then you run this, you get this UI. And you're going to do two things. You're going to click the wireless SSID you would like the server to get on if you're not using a physical Ethernet cable. And if necessary, you type in the Wi-Fi password. And then you choose which device has the SD card plugged into it. So in this case, there's only one SD card. And you click that, and it then proceeds to write the OS image to the SD card, and then also the Wi-Fi password, as well as a key that is then used later for the client to rendezvous with the server once it is booted. And so let's... So after you have flashed the image using that app, you then plug it into the server and then go here to create an account, which I've already created. There we go. And so that'll then take me into the App Store. And so in this case, we've only got one app available, and it is email. So I'm going to start that. And so while this is running, I'll talk you through what's actually happening, because just watching these progress bars is only exciting for about 5 seconds. All right. So I kind of talked a little bit about the different containers, but here it is graphically. So what it's doing is downloading all these individual containers, and then it's going to start them up. And so the flow when we get an email is that it comes into the SMTP server on port 25 from the internet. So that's actually listening to the entire world. And then it will then be forwarded using LMTP to a spam assassin container. And these first two containers can actually are being created on demand and then tore down when they're done. And then spam assassin, once it's done processing the email and decided whether it likes it or not, it's going to then send it along to the IMAP container. And then at some point, hopefully fairly soon, your tablets and phones and laptops and so on are going to come over the zero-tier overlay network and connect to the IMAP port and get the email. And then if you click respond, then it's your client is then going to send over these overlay network to another instance of postfix that can also be torn down after each use, which then reaches out and sends it to the destination SMTP server. So it's a fairly normal kind of setup for email, except for all of the components are running separately, and the ones that are stateless can be restarted. And so, wouldn't it be nice if we had real end-to-end encrypted email that everyone uses? And some of us do, using GPG or SMIME or whatever, but it's pretty rare. I think probably the percentage of people in this room who regularly use GPG to send emails, to sign and send encrypted emails is probably about 4 orders of magnitude higher than the general public, maybe more. But we do actually have an interesting property here that you don't normally have. So if someone sends me email using this exact same setup, it's hopefully encrypted on their client because their laptop disk is encrypted or their phone is encrypted. It's sent over a TLS session to their home server. It's then sent to my home server over a TLS session, and then sent over a different TLS session to my phone. And so the email is never actually in plain text on any network segment. It's never plain text on any disk. And most important, it's never plain text at all on any device that isn't owned by either me or the person I'm communicating with. So this isn't as good as Signal. So if you're planning something particularly sketchy, I would definitely recommend using Signal. But this is a lot better than just normal email for most setups for most people. And of course, it doesn't help you if anyone is using Gmail on your CC chain. Check on that. Okay, that install is still going. Okay, so many of you who run your own email servers have probably already jumped to some of the technical problems I've been glossing over. The first one is that pretty much every residential ISP out there blocks outgoing SMTP port 25. And even if they don't, everyone blocks incoming port 25 from residential IP address ranges because botnets produce a huge amount of spam. So if we want to get our emails to be delivered, we have to proxy them through a clean IP. Now this instantly creates a problem, which is that proxy is going to see the traffic. So there's a cool trick we can pull where you have a proxy that works just at the TCP layer. It doesn't actually terminate the TLS session. So the TLS session is negotiated end-to-end from the sending SMTPD to the receiving SMTPD going through this proxy. So if the proxy attempts to terminate the session and initiate a new one, that'll fail the certificate test. So the sender can be confident that the proxy cannot see the contents of the message. Now, it can see some amount of information and it knows that this IP address sent a message that was approximately this long to that IP address. And so you could envision inserting Tor in the middle to try to hide those IP addresses and hide who's communicating a little bit better. But this at least gets us to where Gmail will actually accept our SMTP sessions and hence our emails. So everyone probably was cringing while I said that about the proxy because this is the spam cannon, right? Like the second the spammers find out about this proxy, they are going to have a field day. And so actually for a while I thought this might have been an unsolvable problem because it's very difficult to rate limit when you can't see the content of the message. And the reason is, if I see 10 megabytes of traffic going through this proxy to Gmail, I have no idea if that's a 1 kilobyte message with hundreds of thousands of recipients listed, or it's just one picture going to one person that you just want to see a picture of your vacation. And so I just despaired a bit that I would ever be able to solve this. But then I realized it turns out that the messages coming back are not controlled by the spammer. That's controlled by the receiving SMTPD. So it's unlikely to do anything unusual or sketchy. And each time you send that RCPT2 with the email address, you get a response back. And so by measuring the number of bytes coming back, I can estimate the number of recipients that are involved in this email message without actually having to expose myself to the plain text. It's not precise, of course, since it's based on number of bytes, and I don't know how big the email addresses are. But if I'm willing to, have some slop, and the rate limit is 20 messages a day, or between 20 and 40 messages a day, it all works out. then the last problem, which is the most annoying one, although it's the least widespread, is that you're starting to see a lot of CG-NAT, and occasionally even just blocking incoming port 25 by ISPs, just because, I don't know, it was easier to block both directions than to figure out which direction it was going. I don't know why they do it. And also, I'll talk a little bit more about this later, but the last piece of this that most people don't know how to do is configure their router to forward ports. I presume everyone in this room knows how to do it, but it's not kind of general knowledge. And we'll talk about that a little bit more later. And so the solution here is to have a reverse version of the proxy. And so it basically does something analogous to vhosts for HTTP or TLS SNI for TLS sessions, where it uses the MX record name and the ehello command coming in from a new connection to demultiplex which of the potentially zillions of clients or SMTP servers out there this message is actually intended for. And it has the same negotiation of the TLS session all the way through, so this proxy can also not see any of the actual content of the messages. And so finally, I can't really do much about this right now, but these are some problems I see. It's all fine and good that you can look at the source code to all of this stuff, verify it does what it says on the tin, but that doesn't really help you if you have no idea what the binary image you're actually running does. Even if you do know that the binary image maps directly to the source, there could still be kind of hidden things hidden away in the source that you haven't seen or that everyone has missed. Now, we can't solve the second part. That's still an open question, but we can solve the first part, and that's with reproducible builds, which we're all missing the talk on. The other big one is that you can have an all open source stack, but if there's firmware under the whole thing that's doing whatever the firmware does, you're kind of at its mercy. There are solutions on x86. I've seen a lot of X220 laptops presumably running core boot here, but they're definitely not widespread. And so there's a lot of work to go there. Raspberry Pi is a little better in that we are fairly close to a fully open source GPU blob that can replace the Broadcom proprietary one and boot the platform. Although that said, the Raspberry Pi 4 just came out and will presumably require more reverse engineering to figure out how its binary blob behaves. Let me check on that. All right, so the app is fully installed. And if we look, so a couple things to note here. There's actually an interesting dovecot bug where after installation, it will spend like 10 minutes trying to generate SSL parameters, but only about 20% of the time, and it looks like we've gotten lucky. So now, there's a couple of things to note here. There's HTTPS, so it's generated a Let's Encrypt certificate behind the scenes. You'll note that there's the domain name is tennille.boundery.me. And so boundery.me is the domain I registered for this service. Tennille is the username. That's actually my wife sitting here. She ran this demo last, so I just reused her account. But the way this works is that when I do this DNS lookup, what it did is, it did the normal, go to the root, get the DNS server for .me, and then asked ME for boundary, got the DNS server for boundary, and then it asked my DNS server that I run, hey, I'm looking for Tennille. And normal DNS services would then give an A record saying, hey, Tennille's at this IP address. But what this one does is sends a start of authority saying, hey, I don't know about any subdomains for tennille.boundary.me, but I know who does. And it gives the IP address of the actual home server. And so then the subdomains are then all actually being handled by a DNS server running on the home server. So then, and so really that was just a very elaborate way to show everyone the Roundcube web UI, which you've probably already seen. But since we're really going to tempt fate here, I'm going to send it a message. And then I will. There we go. Thank you. That was a lot of moving parts for something that in the end doesn't look all that impressive. But hopefully everyone out here, everyone who's hosted a mail server understands just how many like annoying things got taken care of automatically. So, you know, as I said, we just started with email mainly just because it's one of the hardest services to host. You've got to deal with deliverability, spam, blocked ports and IPs. But once you've got that, there's like lots of other things, like WordPress with ActivityPub. You know, maybe we can start chipping away at Facebook and all those services, or you know, photo sharing service that doesn't involve you uploading all of your pictures to someone who's definitely going to do facial recognition on it and then do God knows what with that information. Your IoT devices, you know, in particular security cameras, but it would be nice to be able to still control my house if my internet goes down. And then file storage, kind of replace Dropbox with something that doesn't give a Silicon Valley company plain text access to all of your files. Mastodon, GitLab, there's, you know, tons of awesome open source software out there that, you know, many of us use, but are not easily installable by relatively untechnical users. And so here's where I kind of admit some of the things I glossed over and borderline lied about. I talked about automated backups. That's not implemented at all. There's absolutely no backup going on right now. I have some schemes, and if this sounds interesting, please find me later. I have this vision of like some sort of give a byte, get a byte mutual backup scheme where, you know, I give up parts of half of my storage in return for, you know, 100,000 of my closest friends and family letting me back up my data on their, you know, spare storage. There's a lot of kind of interesting wrinkles around that, which is why it's definitely probably the most complicated part of this whole thing. I alluded to it a little bit, but you have to manually configure your router. Some routers have this like DMZ feature where you can designate a single host for, you know, anything that doesn't match a more specific port forward. It just sends the packets there. But you know, not everyone wants to use that. Not everyone even knows that that's there. And UPnP does not help. And this is actually really annoying because UPnP sounds like the perfect solution for this, except for the protocol that allows any device on your network to port forward any port to any other device on your network for security reasons will not let you forward ports under 1024. So forwarding random ports to your smart TV, A-okay. Forwarding ports under 1024, so my current best thought here is that I bet most people's admin password for the router is either written on the bottom of the router or is admin. And so you could envision the app saying, hey, you know, we need to configure a router. If you know your admin password, punch it in here. And if not, it's probably admin. So if you're OK with it, I'll just try that. And then you can kind of figure out the web UI for the 5 or 10 most common routers out there, and figure out how to automatically punch those portholes in them. And then I talked about mobile apps, but really right now it only supports Linux, Mac, and Windows clients. The common mobile platforms are something of a pain to work with. So I've been working primarily on desktop platforms, but that will need to happen at some point. And so if that sounds interesting to anyone, the code is up on GitLab. We have an IRC channel that's almost certainly just me right now. And if anyone thinks this sounds interesting but doesn't want to contribute, you can email me and I'll let you know when I have an actual image that you can just download and use if your interest is more kind of as a user versus a developer. So yeah, thank you very much.
You mentioned need for open proxy for SMTP and IMAP and other protocols. So how do you imagine that ordinary users will have this proxy? Will they need to have some other machine somewhere else? Because I'm somehow missing this.
Yeah, great question. So right now I'm running a proxy, and so a lot of that, the TLS end-to-end support was specifically to make it so that you don't necessarily have to trust my proxy that I'm running with your email data, and but instead can rely on the TLS guarantees and certificates to verify that it's not snooping on you. And similarly, it has to be able to demultiplex, which on the outbound side is easy because you can just tell it where it's going. On the inbound side, you have to kind of do some tricks around the MX record in the ehello command. Does that answer?
Any more questions? Well, I think that's a fantastic initiative.
Thank you.
And good talk, thanks.